Guys, what's up? You know what? Today I'm taking a topic which is very important, and this is to explain you the mechanism of Reimer Tiemann reaction, which I felt it should be done. So, what Reimer Tiemann reaction is about? Let me introduce you to that. You know, it's a conversion where phenol is converted into salicylaldehyde by using three of the reagent. One is sodium hydroxide or potassium hydroxide, maybe, along with chloroform and water. So these three reagents with phenol, when react, it produce salicylaldehyde, and a very important compound, right? Now, that's not the only thing I wish to do. So mechanism is going to be very much important here, because this will give you an extra boost, or this will give extra confidence to get through organic chemistry reaction, right? So let's see first the reaction, and then we will come to the mechanism part. So like I said, our reactant is phenol. So phenol is our reactant. What you need to do, you have to use two reagents at the same time. One is NaOH and other is chloroform, CHCl3. And by doing so, you obtain an intermediate here, and that intermediate looks like this one, ONA. It's a sodium phenoxide, but as per NCERT, there is something like this here. And then in the last step, it undergo hydrolysis. What that mean? It react with water, and this acidification result, hydrogen shifting over here, and finally it produce the salicylaldehyde. And this salicylaldehyde exactly looks OH right here and CHO right there. So this is your salicylaldehyde. Salicylaldehyde, and a very important compound, right? So this is the Reimer Tiemann reaction. Now the question is how this reaction exactly happened and resulted formation of salicylaldehyde. So we need to move to the mechanism here. So mechanism is going to be very, very interesting for you. Okay, so the thing is, this reaction not start with phenol first. First it start with the chloroform. So let's see how this reaction start here. The chloroform is a tetrahedral molecule where three chlorine atoms are arranged something like this, with one of the hydrogen right here. You do know that the chlorines are highly electronegative, so all the electrons are polarized towards them. What that means? This hydrogen is highly acidic. This hydrogen is highly acidic. And then first molecule of NaOH, is used here. And this, you do know that this acidic proton and this OH molecule can result formation of a water molecule, which is also a leaving group. And by doing so, this electron move towards the carbon and result formation of there are three chlorine here, and now carbon has a lone pair and a negative charge also. This doesn't, it has a negative charge and a lone pair. But another thing that you do understand, that chlorine is a highly, leaving group. It's a leaving group that prefers to get out. So for doing that, one of the chlorine, one by one the chlorine comes out, and for making it go through, I have to do a cleavage something like this. So chlorine will come out with a chloride ion, and this result formation of a wonderful chemical Cl. There is another Cl, and there are lone pair here. Now the neutrality has been maintained. I hope you can see that. In case you do not, let me give you some space as well. So this happens something like this happens, you got carbon here, and you have a lone pair. Now only have two chlorine attached to the carbon and no negative charge, and this molecule is called dichlorocarbene. This is called dichlorocarbene. Carbene is a very important term for competitive exams. So this molecule, which have a lone pair, it seems it's a nucleophile, but it's not. Why? Because it has only 6 electrons around it, 2, 4 and 6, and therefore it acts as a Lewis acid. So this acts as a Lewis acid, and this is the initiating molecule for the overall reaction. Now we can start the reaction and see how this molecule is initiating. So let's take the phenol here. This is your phenol here, a phenol molecule like this, and then first NaOH molecule, it's not first, it's actually the second one. So second NaOH molecule comes in picture, and this result again formation of a water molecule by taking up the proton from here. This proton move towards the OH to form water, and this result formation of a phenoxide ion. This result formation of a phenoxide ion, where you have double bond right here, another one right here, and you have oxygen with 3 lone pair and a negative charge. But then it start resonating, it undergo plus R effect. This molecule undergo plus R effect, and you do know what plus R effect means here. It means that this lone pair shift toward the nearest single bond, and this pi bond shift to the ortho carbon. By doing so, it result a molecule similar to this one. So you have now lone pair over here with a negative charge. Now oxygen here is having a double bond, and oxygen is neutral here, and the 2 pi bonds are still there without having any change. Okay, now the dichlorocarbon comes in picture. So what happened? Just pay attention here. This carbon is electron rich. However, this carbon of dichlorocarbon is electron deficient. So by doing so, this has to make an approach right here. So it approaches the this phenoxide ion, and it result formation of a molecule which looks like to be, you have a double bond right here, another one right here, you have a double bond oxygen here with 2 of lone pair, and then this one is now connected to dichlorocarbon here, dichlorocarbon. But you need to remember that there is a hydrogen as well. Like most all the carbon in the benzene has a hydrogen, which I'm not showing, but you do understand there are. Now, since carbon has taken the electron from there, I'm changing the direction of the arrow here. So what that means, carbon is having a negative charge. Because this carbon is having a negative charge, it just to make sure that it becomes neutral and the aromaticity is maintained, what will happen? This bond will undergo cleavage. This bond will undergo cleavage, and this will result restoring the aromaticity. But in order to do so, this pi bond again go back to the oxygen, right? And this proton is finally taken up by the carbon here. So just pay attention here. Carbon is having a negative charge, and that's why it's unstable and it's ready to take up the proton from here. So once the proton is taken up by the carbon, this pair of electrons shift to the benzene, but just to make sure that aromaticity is restored. But then this pi bond again shift to the oxygen, and that's how now I'm out of space here. So this reaction, I'm making it move towards this direction. So what happened? This aromaticity is restored, this become a single bond and hydrogen attached to the carbon itself. So you get a structure something like this. You have a double bond right here, another double bond here, but now carbon is having 1 hydrogen and 2 chlorine. 1 hydrogen and 2 chlorine. Now the aromaticity is restored. Oxygen is now having 3 electron and a negative charge back again. So this is what happened right here. Now the question you might be having, why we only stopped the resonance at the ortho and not went towards the para? It's because when salicylaldehyde is formed, it result formation of additional hydrogen bond here, intramolecular hydrogen bond. So that's why ortho product is more preferred here due to an additional hydrogen bond formation. Although you do understand that paras are more stable, but because it gives an additional hydrogen bond formation if the salicylaldehyde formed is at ortho position, that's why most of the products are formed at ortho position. So I didn't take you through the para one, right? So this is what the product is coming out. Now just pay attention here again. Now another 2 molecule here, just pay attention, another 2 molecule of sodium hydroxides come in picture. And what happened? These 2 chlorines, just pay attention, these 2 chlorines are substituted by the by the OH. Why? Because sodium prefer to go with these chloride. So what that means, you form 2 NaCl, and you have 2 OH right at these 2 places. So the products are, you have your first pi bond right here, another one here, and third one right there. You have oxygen with 3 electron pair, and this carbon is having now 2 OH. I hope it's not messing up. This carbon has 2 OH and a hydrogen also. So finally the question is, what will happen? You do know that 2 hydroxide ions are not stable on the same carbon. So it result elimination of a water molecule. So what is happening here? H2O is coming out, and as the H2O is coming out, this oxygen, which will develop a negative charge. By doing so, it restore a pi bond between carbon and oxygen, and you get your product, almost, your product, which is, C, and you have double bond O and H as well, and there you have your oxygen still with a negative charge. In the last step, what happened? I place the remaining 2 pi bonds here. In the last step, this undergo acidification, and this acidification result formation of the salicylaldehyde. And finally, this acidification result formation of salicylaldehyde here. So you have your aldehyde group here, and you have your OH right here, which is your salicylaldehyde. Right? I hope I didn't mess up, because lack of space was a situation here, but I tried my best to make you. Let me repeat back what happened. First, we used the chloroform and reacted with sodium hydroxide. It result formation of dichlorocarbene. Dichlorocarbene is a very important term, and it is an initiating chemical substance. However, this comes in picture right over here, but before that, phenol react with sodium hydroxide, resulting formation of water molecule and resulting formation of phenoxide ion. This phenoxide ion undergo plus R effect to produce ortho, electron rich product. And why ortho? Because at ortho, an additional intramolecular hydrogen bond is formed, which gives stability to the salicylaldehyde, which is not possible if it's formed at the para position. And after that, this being a negatively charged, the dichlorocarbene being electrophilic or Lewis acid, it contact with the carbon and it forms intermediate, something like this. Finally, you get this product intermediate. Then you have to use 2 of the sodium hydroxide, which will result formation of 2 sodium chloride, but replacement of 2 chloride by the 2 OH ion. So you get OH at these 2 places, but along with that you have hydrogen also. And finally this result protonation, and protonation result formation of the salicylaldehyde. So I hope I have made you go exactly it should have been. And in case there is a doubt and you wish to find out more, do let me know through your comments, and you can also even contact me personally. That's what I can do. So with this, I'm going to say thanks for watching, take care, and have a very good day.